Okay, so now you notice that I've already been able to draw the two scales that are definitely involved, and that is the Fahrenheit scale and the centigrade scale. Now you'll notice that when we put the, the thermometer, which is graduated in Celsius, you will notice that in degree centigrade, you will notice that the reading, right, we obtain from the boiling, right, from the boiling liquid in the container. Of course, that is the container, right? I will obtain from the boiling content or from the warm content in the container is Xc. So I'm going to call this here the Xc. So let us just say the Xc is that is the reading obtained. And that reading obtained here is equivalent to the reading obtained on the Fahrenheit scale. So I'm just going to make sure this is equivalent. Did you see I'm going to do that? It's definitely equivalent, right? It's equivalent in length, right? It's equivalent in length to YF, right? Although different value, but it is equivalent in length to YF. Just like the meter and the centimeter are actually measuring the same length AB, but the value is definitely bigger than one another, but in length is the same. And what am I going to do from here? Now from this sense, I'm going to try to make some good conversion. So let us make some good conversions here. To do the conversion, I'm going to be using the principle of fundamental interval, right? In ratio, just like a bigger scale over the smaller scale. And that is going to be very simple to do. I'm going to take xc over xc minus 0, and that's going to be what I'm going to do here. So it's going to be xc minus 0, right? And that should be divided by 100 minus 0. Did you see in segments there, right? And this should be equal to, you can make that a little bit more obvious, minus 0. And that will be equal to, in the basic, YF minus 32. So YF minus 32, right, divided by 212 minus 32. 212 minus 32. And in this case, XC minus 0 is going to produce XC, right? And that is over 100 minus 0. That's going to be producing 100. And this will be equal to YF minus 32. That stands the same, right? I guess it's still going to be YF minus 32 over 212 minus 32, and that will produce 180 degree. Did you notice that the 180 degree in here and the 100 in here are definitely the fundamental intervals of the degree centigrade scale and the Fahrenheit scale? In that end, we can move up from here, right, by getting more principle, right? Let's put this across here. Just going to break this into pieces, right? And of course, I'm going to have to move this right now. In this case, we can definitely like make an adjustment, right? And in this case, it's going to be xc multiplied by 180 degree multiplied by 180 degree, right? 180 degree Fahrenheit, of course, right? It's just going to like that slide, and this is 100 degrees Celsius. So 180 degree Fahrenheit, right? That should be equal to, I hope you're still following in that case. That's going to be this, multiply this, and then 100 degrees Celsius to multiply this. That'll be 100 degrees Celsius, right? Multiply by, right? We tend to have a bracket there, and that is going to be YF minus 32. Right? And in that case, you will notice just from this case here that I could actually divide both sides by 180 degree, right? 180 degree in this case. So I'm just going to let the F slide. So I'm going to be dividing both sides by 180, right? So I'm going to be dividing here by 180, and I'm going to be dividing here by 180 degree, right? And if I do that, of course, you notice this, break this out, right? Single zero, break a single zero out here. 2 in 10, that is going to be 5. 2 in 18, that will be 9. And in that case, right, it will be giving me XC to be equal to, right, and that produce 5 over 9, right? And of course, I have my bracket, which is this bracket here, and that's going to be YF minus 32, close the bracket. And of course, this is the formula, right? Or should we say relationship, right, between the Celsius scale, right, the degree centigrade scale, and the degree Fahrenheit scale. So with this formula, I can make my conversion, right, between the two scales, right? So let us assume from this question right here now, right, if XC, right, if XC in this case right now, if XC in this case is given to me as 30 degrees Celsius, and I need to obtain the value of, in degree Fahrenheit, and that is why F is unknown. And to do that, right, you can make an adjustment to that by saying that 30, sorry, should have been in another color, and that's going to be 30 equal to, right, and that produce 5 over 9, is that not, right, going into the bracket of YF, right, minus, in that case, 32, right? From there, I can multiply both sides by 9 over 5. You can multiply both sides by 9 over 5. That is by the inverse of 5 over 9, right? If I do that, this to cancel that, 9 to cancel 9. And in that case, I'll get my 9 multiplied by 30. That will be 270, right? So that will produce 270 over 5 in this case. So I guess we are on the same page, 270 over 5 in that case. And that's going to be equal to, on this side, YF minus 32. Don't forget, I'm looking for YF. I'm going to have to take 32 outside of the scale. So 32 go outside. Is that not? And that's going to give me 270 divided by 5. That's going to be 54, right? So I'm getting myself 54, right? And that's 32 coming in that direction. Produce plus 32 equals YF. Now I can add 54 plus 32 right there, and that will give my YF to definitely be equal to 86, right, degree Fahrenheit. Now you can see that it was 30 degree in this case, but right now it is 86 degree Fahrenheit. So in that end, it is the same length, the same temperature is measured, right? But of course, the quantity or the magnitude is different. The magnitude, right, or the quantity is different, or the values are different across the same magnitude.